Hello, Algebra. We are going to talk about another function. Do you guys remember the first function we did? What was it? Linear. Lines. Next one. Quadratics. Parabolas. Next one. Square root. And now, rational. And we also had talked about briefly the absolute value function, which is like a v. Square root is more like a half of a parabola, kind of a curve. So, all right, let's get our definitions down first. Rational function is a function whose rule is a quotient of polynomials. That's it, a quotient of polynomials. Now, you learned yesterday about the inverse variation, or last Friday, whichever it is, in 12.1. That was a type of rational function, of a rational function. Okay, that was just one specific type of a whole realm of rational functions. Another term you're going to hear is excluded value, and that is any x value that makes the function value y undefined. So specifically now, because that's not specific to the rational ones, but specific for a rational function, which is the one we're going to be talking about here in this section, it makes the denominator 0. Because what happens, class, when the denominator is 0? It's undefined. That's correct. We cannot divide by 0. So therefore, anytime if we have up here a quotient of polynomials, a quotient is a fraction, and if we have a 0 in the denominator, that makes it undefined. So we would exclude from the domain any value that would make that bottom a 0. So for example, identify the excluded value for each rational number. So when we look at this is an inverse function, isn't it? From what we learned yesterday, an inverse variation. What would make this 0 if x was what? That one's almost too simple that it's hard, right? 0. So if x was 0, that would be undefined. So that value is excluded. X could be anything else. But we're going to exclude. We're going to take out. Exclude means to take out or leave out. We're going to take out or leave out the 0. We're not going to include that. What would make the bottom 0 there, class? That's right, a 2. So that is our excluded value for that one. Okay, we want to pick any other x value for the domain. Domain is our x values, remember, except 2. Because then it won't be defined. Now, discontinuous functions. We talked about this briefly before. Remember, continuous functions or lines were things that didn't have any break in them. So it was like a linear function is a line. That's a continuous function because it never has a break in it. Well, we're going to be talking about this, which does have a break in it. But a discontinuous function is when their graphs contain one or more jumps, breaks, or holes. Okay? Just like we talked about. It's not one continuous thing. You have to lift up your pencil to continue writing that graph. All right, and then we're going to talk about, this is the way you pronounce this is asymptote. Okay? And the asymptote we're going to talk about in detail on the next cool page, which hopefully you got colored because it's even cooler colored. But let's get the definition. It's a line. Hear that? It's a line. Okay, it's a line that a graph gets closer to, but never touches it. So it just gets closer and closer and closer and closer, but never touches it. And specifically in this section, rational functions that we're going to be talking about are discontinuous at the asymptotes. Okay? At those lines. Remember, they're lines. So once we find these lines, we know that it'll butt up to it. And I'm going to show you what these pictures look like for irrational functions in just a second. I first have to show you how easy it is to actually find the asymptotes. So in an equation, when you have it equal, what you're going to have is y equals, it's going to be a fraction, and then sometimes we're going to have something added. In this case, there's nothing there, so it's like it's adding a 0. But do you notice the similarity over here? So we got a fraction adding an 8. Well, here is the deal. The excluded value, what would the excluded value be here? That's right, -7. It's whatever makes this bottom 0. That is your vertical asymptote. And to get the y one is even easier. That's your y one. Y equals 0. That's your horizontal asymptote. So isn't that cool? So again, I'll show you what the asymptotes look like on a graph in 1 second. You'll get a better picture. But let's just finish this. If you can, pause your video and tell me what the vertical asymptote is and what the horizontal is. Okay, so you guys can see the horizontal is easy right there. And if it's nothing's there, then it's a 0, like it was over here. Okay. And then we have to see what makes that 0. That's not as easy to tell, is it? But all you have to do is take it and set it equal to 0 and solve, and you'll get your answer. Because that's what we're saying. When is it 0? So we divide by 2, and x is 3/2, or 1.5 is typically a little easier too. And that's your vertical asymptote. Take good notes. All right, so now let's turn the page to the super cool page, favorite page. Aw, this isn't it. Oh, bummer. Sorry, guys. It's not the one I thought it was. It's coming up. Don't worry. Don't you worry. But let's look at this first. Okay, so this is giving you... Let me fix the camera here. This is showing you the equations. So, just like I taught you, if it is... Actually, if it's in the x minus form, you can just pull that right out. Okay, so the b would be the x equals whatever, because that's what would make it a 0. The c is your y. Okay, if there is nothing down here, if it happened to be a 0, then it would be x equals 0. And if that happened to be a 0, it's y equals 0. It's fine. And if you happen to have a plus value, you could rewrite it. But I think it's easier actually to just think what would make this equal to 0. And I see the +2 and I think, oh, it has to be a -2 then. Or you can set it equal to 0 and solve. All right, I guess we got to wait for the cool map. All right, more work first. Okay, so let's do this. Let's graph this function. So the first thing you want to do is figure out the asymptotes. So what is my x and what is my y? That's right. If you're saying 3 for the x and 0 for the y, you are right on. 3 minus 3 is 0, so it's going to be 3 and 0. Excellent. So I got to draw those. Remember, this is vertical, and this y is the horizontal. So we're going to go ahead and put those in. X equals 3. 1, 2, 3. Oh, whoa, back it up. 1, 2, 3. So we'll go vertical through there. Then I'll do my horizontal through 0. Those are the asymptotes. They'll never touch those. They approach them. And you're going to see how they approach them in a moment. But you're going to now make your nice big XY chart. Okay, and we got to pick some values. So this is a little trickier because what I do is I look for the center because I know it's never going to hit the center where these two cross. And I kind of go forward a few and I go back a few. That's how I know. So 1, 2, 3. So I'm going to start with 0 and go all the way up to, so I'll go 0, 1, 2. Not the 3 because that's not going to hit it. 4, 5, and 6. Okay, do you see how the middle one is missing? That's undefined there. Okay. The 3 is where it would be undefined. So let's put them in there. So we might have to do some work or we might be able to do it in our head. It just depends on the problem. So 0, if we put a 0 in there, 2 over 0 minus 3 equals a negative 2/3. 1 minus 3. 2 over a negative 2, that's a negative 1. Now I'm going to plug the 2 in here. 2 over 2 minus 3. It's a negative 2. I'm going to jump up to 4. 2 over 4 minus 3. That's a 2. Throw in a 5. 2 over 5 minus 3. So 1. You guys noticing the pattern? You should be able to see the pattern here and tell me what that is. What is it? That's right, positive 2/3. Good. So let's graph these. So 0, negative 2/3. And I probably should have made my graph a little bigger, but I didn't. So I'm just still going to go with it. Right here, 1, negative 1, 2, negative 2. So it starts to curve a little sharper. 4, 2, 5, 1, and 6, 2/3. So it is going to curve like this. Oh, here you go. You guys can see this cool graph. And they curve like that. Keep in mind, it never touches those lines, does it? Okay. I guess it's similar in the inverse. I'm forgetting that we did the inverse already. I've done so many videos today, I'm starting to not see straight. But so I'm kind of forgetting that we already did this. But not did this, but we did the inverse, which showed you the pictures here. And I think that actually the cool picture I loved was in the last section, wasn't it? I already showed it to you. Darn it. Well, you guys have it. I love that graph picture where they show you the different ones and the way they look, depending on which quadrants they're in. All right. If I were you, I'd pause it and try this on your own. But I'm going to go ahead and finish it up. So my x is negative 4, and my y is negative 2. Very good. It has to be negative. So negative 4, 2, 4. And negative 2. Let's get the good old grand chart going out. Again, how do I pick these? For those of you that are having trouble, I go to the center, and I'm picking values this way. Okay, so I'm looking over here, and I'm thinking I'm going to start at, say, about 1, 2, 3. I'm going to actually start at 0 today. Okay, so 0, 1, 0, negative 1, negative 2, negative 3. Skip the negative 4 because that's what made that 0. Negative 5, negative 6, negative 7, and negative 8. I'm going to do more just for fun. All right. So y, let's get going. Throw in the 0. I think I'm going to need to do more work, so I'm going to put it over here. Y equals 1 over 0 plus 4 minus 2. So that equals 1/4 minus 2. So we're getting good with our little fractions here. And I'm in my head, I'm thinking I got a negative 2 and a positive 1/4. It's a negative 1 3/4. So if you can start seeing some of that, that's awesome. If you can't, you can either get common denominators, you can use your calculators at this point, so it's up to you. Y equals 1 over negative 1 plus 4 minus 2. So that's a positive 3. So I have a third minus 2. So now I'm thinking, okay, that would be a negative 1 2/3. Not much of a difference there, is there? Next one, 1 over negative 1 minus I'm sorry, negative 2 plus 4. Let's get that right. So that'd be a half minus 2, negative 1.5. These numbers are darn close. Y equals, maybe I'll want to adjust my chart, but I can't because I have my lines. Oh well. 1 over negative 3 plus 4 minus 2 equals 1 over 1 is 1, minus 2 is a negative 1. Finally, I get a whole number. And if this was 0, 0, these probably would reflect, but I got to see what my pattern is first here to see if there's anything that we notice. Let's see. Y equals 1 over negative 5 plus 4 minus 2. So that's 1 over negative 1 minus 2. So that's a negative 3. Y equals 1 over negative 6 plus 4 minus 2. It's a negative 2. So that's a negative 1/2 minus 2. That's a negative 2.5. Oh, do you notice anything? Did I do something wrong? I feel like I did something wrong. Or maybe not. Okay, y equals 1 over negative 7 plus 4 minus 2 is a negative 1/3 minus 2, so a negative 2 1/3. And lastly, y equals 1 over negative 8 plus 4 minus 2 equals 1 over negative 4 minus 2. That's negative 2 1/4. Woofda! We got a lot going on in a little bit of range, don't we? Okay, so 0, negative 1 3/4. Some of these are just going to not look really good. 0, negative 1 3/4. Negative 1, negative 1 2/3, so slightly above it. Negative 2, negative 1.5. Negative 3, negative 1. So that's kind of crummy because that's hard to see the change there. We'll go with it. Negative 5, negative 3, negative 6, negative 2.5, negative 7. See, so it just slowly starts getting closer to that line. And we are done with that. So, pretty much done with the lesson. I just want to show you the last 2 pages, and it's just a review of what we talked about at the beginning. So it's just to wrap up the whole year here, really. We talked about linear, so I'm hoping you guys remember that now. Like that's part of your base knowledge is your linear function. That's your slope, that's your y-intercept. Like I want you to feel comfortable with that. This is your quadratic. And we talked about all different ways to work with the quadratic. If it was positive, it turned up. If it was negative, it turned down. We can get the axis of symmetry. This tells us if it translates vertically. And then now we have 2 more, if I can ever get them apart. Now we spent a ton of time on these 2. These were the main ones we did. These would not so much at all. But so notice that A tells you, if it's a minus, tells you which way it translates, and B tells you which way it goes up or down for the square root function. And then the rational one, that's our new one today. So that tells you where it goes horizontally, what makes it 0, and that tells you your vertical. Okay? So, pretty cool. Good stuff. I hope this helps, and I will talk to you later. Have a good day. God bless.